Okay, so welcome into this next video in which we are discussing the mechanism of action of Mitomycin C. Okay, so we want to now discuss how Mitomycin C is activated. So the first thing that's going to happen is you're going to reduce the quinone moiety here. Okay, so to reduce it, what you bring in is 2 hydrogen atoms, and I'm not going to say specifically where you get these from because there are a number of examples. What we know is that you need to bring in 2 hydrogen atoms. So let me be very clear what I mean by this. I don't just mean the protons. I mean that you bring in 2 protons, 2 hydrogen nuclei, and also 2 electrons. So you have the pure atoms basically that you are bringing in here. Now, what you're going to do to your Mitomycin C molecule is you're going to break, you're going to break one of the bonds of each of these carbonyl groups. So, where you've got these carbons doubly bonded to the oxygens, you're not going to break both bonds, but you're going to break one bond. Now, when you do that, you can imagine one electron is going to go back to the oxygen, and one electron is going to go back to the carbon. Okay, same up here. So the oxygen's now got a free electron in both cases, and the carbon's got a free electron. Now, what's going to happen with the carbons? Well, they're going to basically form double bonds. So what will happen is this will return to a benzene ring. So at the moment, what you've got is this carbon and this carbon have got a double bond, and this carbon and this carbon have got a double bond. What will happen is this carbon will form a double bond with this carbon, okay? Which means that this carbon will have to break its double bond with this carbon. So this will break, okay, so let me show this happening. So this is also going to break, but then what will happen is this carbon will form a double bond with this carbon, basically. So that then is going to make everything nice and equal, except for the fact that these oxygens have now got free electrons. Well, they're going to bind with the hydrogens. So you're going to bind 1 hydrogen atom on here and 1 hydrogen atom on here. So if we now draw the modified Mitomycin C, then we have this 6-membered, now a benzene ring here, okay, where you've got a double bond here, a double bond here, and a double bond here, okay? And then we've got this 5-membered ring coming off here. Okay, so here's this 5-membered ring, and all of this now is unchanged. So here's this 5-membered ring, and then we've got this other 5-membered ring coming off down here. Okay, and then coming off this 5-membered ring at the bottom here, you've then got the Aziridine ring, this 3-membered ring here. Okay, then we've got this methoxy group here, oxygen linked with the CH3, and then finally this methylene group, which is ester linked to the carbamic acid molecule, well, the carbamoyl group over here. Okay, right. So then just complete this 5-membered ring now. We have alcohol groups up here rather than carbonyl, that's better, carbonyl groups. And then you've got an amino group off here, and then the methyl group is still here. Okay, so that's the first step of the activation. Now what we're going to do is go for another step of the activation. So this next step, what you're going to do basically is cut off this group here, okay? And you're also going to chop off one of the hydrogens that is bound to this carbon here. So we've drawn the skeletal structure, but think about this carbon that's here. This has got 3 bonds that I've shown, which means that the 4th bond must be to a hydrogen atom. We're going to break that bond between this carbon and the hydrogen atom. So you're going to get a hydrogen atom coming off, which will bind to this oxygen atom here to make methanol. So one of the products you're going to get is CH3OH, which is methanol, okay? And then what is also going to happen is this carbon will now have a free electron, and this carbon will also have a free electron, so they form a double bond. So the next step, okay, is this 6-membered ring up here. This is now unchanged. So this is still a big benzene ring here, okay, with these alternating single and double bonds. Then you've got these alcohol groups coming off here and here. You've got the amino group here and the methyl group here. Okay, and then you've got this 5-membered ring over here with the nitrogen down here, and then another 5-membered ring, and I'll just make that actually join up here, and then finally the Aziridine ring over here. So you've taken this methoxy group off and formed a double bond there, but this other group with the methylene esterified with the carbamic acid group over here is still there. So this is all still present. So this is where we've got to so far. We've got to this structure here. Okay, right. So let's go to the next process now. The next process, what you're going to do is you're going to break the Aziridine ring here. Okay, so this is now going to actually break open. So let's start this process off then. So the first thing you're going to do is you're going to break this bond between the nitrogen and the carbon. So the nitrogen's now going to have a free electron, and this carbon's going to have a free electron. What you're then going to do is you're going to also break this bond here, this double bond that we've only just formed. But never mind, we've only just formed that, but that's now going to break. So it's going to give this carbon and this carbon back their free electrons. So what's then going to happen is this carbon here with its free electron and this carbon here with its free electron are going to form a double bond. Okay? Then this carbon's going to have a free electron. So next what's going to happen is this double bond here is going to break. Okay? And that will give this carbon and this carbon free electrons. This carbon will use its free electron to bind with the free electron of this carbon, so you'll get a double bond forming here. Okay? Finally, this carbon up here has got a free electron. It's then going to cause the oxygen to break its bond with the hydrogen atom, and that will give the oxygen a free electron to bind with this carbon. So you're going to produce the carbonyl group back again. Finally, this hydrogen will now be free, so you've got a hydrogen atom here, a hydrogen nucleus and an electron free, and that will bind to the free electron of this nitrogen. Okay, so let's draw that happening, and I think I'll try and squeeze it in down here. So we've now got our 6-membered ring up here. Okay, like so. And we've got these two double bonds here. We've then got this carbonyl group here. Okay, we've got the amino group here and the methyl group over here, and that should be bound like that. Then we've got this 5-membered ring coming off here. We've now got a double bond here and no double bond here, so just a single bond there. The 5-membered ring, apart from that, is still the same, and now you've got a ring here, this 5-membered ring here, but this bond here now is also a double bond. And also, this bond's now broken, so you've no longer got the Aziridine ring formed anymore, and instead you've got an amino group down there. Okay, so up here then, the methanol group, the methylene group rather, not the methanol group, the methylene group, is still linked via this ester link to the carbamic acid group up here, or the carbamol group. Right, so that's where we've got to so far in this activation of Mitomycin C. Now what's going to happen is the Mitomycin C is actually going to bind to guanine organic bases upon the DNA, but we'll discuss that in the next video.